Okay, today we are going to do some operations with limits called limit laws or property of limits. And there's just a lot of text on this paper, so you don't have to jot this all down in your notes. You would spend a whole lot of time writing, and it's not really that hard of a topic. But the second slide that we do is going to be really important to pay attention to some tricky examples. So let's go ahead and dive in. Just kind of listen as I do these first few examples. They're really pretty straightforward. Okay, so I'm given some limits at the top of this table, and in order to apply the limit laws, the limits must both exist. Okay, so look at the bottom of the screen here. So it's saying in order to apply the limit laws that I'm going to show you, both the limits must exist. Okay, so the first one, limit as x approaches 3 of 7. Well, the limit of any constant is just equal to that constant. Because if you picture what's happening on the graph, the line y equals 7 is a horizontal line going through the y value of 7. Anywhere I go on that line, the limit's going to exist and the limit is going to equal 7. So the limit of a constant is just a constant. So moving to the right, when we add to the limit of two functions, we can add those limits separately. So we're adding the limit as x approaches 5 of b of x, which is negative 0.5. And the limit as x approaches 5 of a of x, which is 4, so we get 3.5. In a similar fashion, we can subtract. As long as both limits exist, we can subtract. So notice that the instructions told us to find the limit of the difference of the functions, and we are finding the difference of the limits. So you're allowed to do that. In order to find the limit of the difference of the functions, we're finding the difference of the limits. Okay, next one, we're dividing. 4 divided by negative 0.5, and that gives us 8. And then we're multiplying. Okay, limit as x approaches 5 of a of x, so we're square rooting 4. So this is telling us to take the limit of the square root of a function. So what we just did is we took the square root of the limit of the function, and you're allowed to do that. As long as the limit exists, in order to get the limit of the square root of a function, you can take the square root of the limit. We're just multiplying here a limit by a constant. That's allowable. And we're multiplying here by negative 0.5. Okay, next we're cubing a function and then taking the limit. That's going to give us the exact same answer as if we take the limit as x approaches 5 of b of x and cube it. So when we cube negative 0.5, so let's go up to the top and do this work here. Negative 0.5 cubed, when you cube a negative, you get a negative, and I believe it's 0.125, yeah, negative 0.125. Okay, now we're going to do a composition of functions. So I'm going to do the inside first, limit as x approaches 3 of b of x. And you've seen, I believe, this kind of problem before. Limit as x approaches 3 of b of x. Up here in the table is 2. And then we're going to do the limit as x approaches 2 of a of x, which is 7. So you apply the limit on the inner function first. So the limit as x approaches 3 of a of x is 5. And so then our problem becomes the limit as x approaches 5 of b of x. Okay, I think since we've done those problems before, I think you're probably good enough if I skip those last 2. But those are some things that we can do with limits that exist. We can add them, multiply, divide, raise them to powers, apply composition of functions, which are the ones on the bottom. Okay, now let's do the same thing from graphs. So the limit as x approaches -3 of g of f of x. So let's apply the limit on the inside first. Limit as x approaches -3 of f of x is going to be 0. And then we're taking the limit as x approaches 0 of g of x. Well, here's a problem. Do you see how the limit doesn't exist at 0? So we can't attempt this problem in the same way that we attempted the ones in the table above. And this is a super tricky problem. Super tricky. So if you need to hop into my tutorials today and ask questions about this, or we can discuss it tomorrow in our team's meeting, that would be awesome. Okay, so here's what we're going to do. We're going to find the one-sided limits, because you guys know in order for the limit to exist, the left and the right-hand limits must be equal. So we're going to take the limit as x approaches -3 from the left of f of x first. From the right of fx. Okay, so when we find the limit as x approaches -3 from the left, that gives us 0. But which side are we approaching 0 from? Do you see we're approaching 0 from values less than it because we're coming from underneath? We're approaching 0 from the negative side of it. What about as we approach the right-hand limit as x approaches -3 from the right? That's also approaching 0, but from the negative side of it. We're approaching 0 from underneath. Not coming from the top, not from the positive values, not that direction, but we're approaching 0 from values beneath it. So now, when I go to find both my left and my right-hand limits, I'm going to be approaching 0 from the left-hand side. Because the original left and right-hand limits, when I approach 0, I approached both from underneath. And so now, I'm looking at the limit as x approaches 0 from the left of g of x, and that equals 3. That's going to be my limit. And again, the reason is when we approach -3 from both the left and the right, the limit's approaching 0, but it's approaching 0 from numbers less than it. And so when we go over here to the second graph and find the limit as x approaches 0, we only need to look from the left-hand side. And in essence, we've considered both the left and the right-hand limits. Okay, let's see if number 2 is tricky like that. I can't remember. Okay, so we're going to take let's look at the graphs first, and then if we need to show our one-sided limits, we will. So we're going to take the limit as x approaches 5 of f of x. So we're going to look, limit as x approaches 5 of f of x. Okay, so that's 0. And then again, we look at the second graph, and our limit doesn't exist. So yeah, let's go ahead and find our left and right-hand limits. So the limit as x approaches 5 from the left of f of x. Well, that's going to be 0, but we're coming from values greater than 0. We're coming from above, from positive values. So our limit as x approaches 5 from the right of f of x is 0, but we're approaching 0 from values less than it, or the negative side, the values below the y-axis, and so we're approaching 0 from the left side. So now when I go to this graph over here to find the limit of g of x, I'm first finding the limit as x approaches 0 from the right side, because that's what this 0 plus sign tells me. So limit as x approaches 0 from the right-hand side is going to be 2. And now this tells me that I'm going to find the limit as x approaches 0 from the left of g of x. And that is, looking at the graph, that's going to be 3. So since those are not equal, this is D and E. Okay, let's keep going a couple more. So we're taking the limit here as x approaches -1 of f of g of x. So let's look at the limit as x approaches -1 of g of x first. Limit as x approaches -1 of g of x. So both of those limits are approaching -1, are approaching 2. And then we're going to go to the second graph and find the limit as x approaches 2 of f of x. And that limit doesn't exist. So let's go ahead and show a little work. So first, I'm going to color code this time. So let's get rid of these arrows on the graph. Limit as x approaches -1 from the left of g of x. And limit as x approaches -1 from the right of g of x. Oh, I said I was in color code, didn't I? I'm not. I suggest that you pause the video and try these problems on your own and then resume, because you're going to learn a whole lot more if you kind of struggle with this and wrestle through the work yourself. Productive struggle. So go ahead and pause and try to get this answer and then replay and see what you get. Okay, so let's go back to the blue. Okay, so we're taking the limit as x approaches -1 from the left of g of x. So limit as x approaches -1 from the left of g of x is going to be 2. Coming from which side? Coming from above. So I'm going to put a plus sign here. So then I'm going to go to the other graph and find the limit as x approaches 2 from above. So limit as x approaches 2 from the positive side of 2. Now it's the x value that's approaching 2 from the positive side, and it's approaching an output of 3. Okay, let's go ahead and go back to orange. So now I'm finding the limit as x approaches -1 from the right. So going to this graph up here, limit as x approaches -1 from the right is 2, but it's coming from numbers higher than 2. So when I find the second limit, I'm finding again the limit as x approaches 2 from numbers higher than it. So x is approaching from the right because I have to approach from numbers greater than 2. So that equals 3. So this limit exists and equals 3. Okay, so these down at the bottom are examples of when the limits don't exist, and we can't just use those easy peasy limit laws like we did at the top. Okay, let's go ahead and find the limit. Limit as x approaches 2 of f of x and g of x. So let's look at 2. So at 2, our limits don't exist. So we need to find the left and right hand limits separately. So let's go ahead and find our limit as x approaches 2 from the left of g of x. And that's going to be, limit as x approaches 2 from the left of g of x plus f of x. So the left-hand limit here is 0, which I drew in that graph, and the left-hand limit as x approaches 2 here is 5. Okay, let's switch our color back. So we're going to do the limit as x approaches 2 from the right of g of x plus f of x. And it's okay to abbreviate just g plus f. That's a fine abbreviation. So going to that second graph, the limit as x approaches 2 from the right is 2. And the limit as x approaches 2 from the right of f of x is 3. The left and our right hand limits are equal, and so that means our limit exists and it equals 5. Okay, I'm gonna stop there. This is a pretty long video, and give you some time to attempt some of the ones on your homework. Please show the one-sided limits like I did here for the problems that indicate that you need to do so on the homework.